Hey, this is Mr. Warden. This is Algebra Do Now 25.2, a video key. So here we go. You started today, just like any other day, trying to mix two solutions of dangerous acids to get just the right mixture of acid. The acid in question was hydrofluoric acid. Don't mess with this stuff. Chemists are afraid of it for good reason. It won't hurt you when it first lands on you, but then it starts to dissolve your bones, and that will hurt, and then you probably die. So, you can't even contain it in things because it burns through glass. At any rate, you decided you were going to mix some anyway. So you wanted to mix some 25% hydrofluoric acid, HF stands for hydrofluoric acid, and some 10%. That means water that is 25% hydrofluoric acid and water that is 10% hydrofluoric acid. It's a solution, actually, not to be confused with a solution in a system. However, systems of equations are quite frequently used to solve these problems in chemistry. So in the end, you need 110 liters. That was 16% hydrofluoric acid. So what are the two key unknowns? So we know you need 110 liters. We know that needs to be 16%. We know that you have a sum that's going to be 25% and some other amount that's going to be 10%. So the key unknowns in this are the number of liters of 25% HF solution and the number of liters of 10% HF solution. And we'll just call the first one X. Doesn't matter which one gets called X, which one gets called Y, as long as you stick with that through your whole story. So there you go. X numbers of liters of 25% hydrofluoric acid solution and Y number of liters of 10% hydrofluoric acid solution. Okay, yeah, don't mess with this stuff. Really nasty. All right, so now, if you came up with that 25%, the amount of 25% hydrofluoric acid, the amount of 10% hydrofluoric acid, you got it. So we can represent those as X and Y, and there are two equations we can make. I'm going to do the simple one first. We know that you want 110 liters, and some of those liters are the 25% liters, and some of those are the 10%. So X plus Y equals 110 liters. All right, now the other equation is a little trickier. So the other equation, what we're going to do is we're going to focus on just the part of each piece that is hydrofluoric acid. Well, 25% of X is hydrofluoric acid, and 10% of Y is going to be hydrofluoric acid, and that's going to add up to 16% of 110 liters. So what you've got here, this first one is just the simple sum equation. And this one here is the hydrofluoric acid equation. This is basically the sum of the pure hydrofluoric acid. This is maybe the sum of the portion that is hydrofluoric acid. Okay, so those are your two equations. We can, of course, simplify 16 times 110, and we could, if we wanted, turn that into 0.16 and 0.1 and 0.25, but then, you know what I'm going to end up doing? I'll do that. I'm going to show you what I'll do after that. Okay. You go way back in the Wayback Machine to the equations unit. There was a section in the equations unit called clearing denominators and decimals. So we're going to clear these denominators. These are not denominators. We're going to clear the decimals. So I'm going to multiply every single part of this by 100. I'm going to call that 25x plus 10y equals 16 times 110. And now I do need to work out what 16 times 110 is. 16 times 110 is going to be 16, 160 I should say, plus 1600, because that's 100 times 16 and 10 times 16. So that's going to be 1,760. So I'm going to go ahead and add that in there. 1,760. That'll be a little easier to work with. So our final equation is going to end up being 25x. Well, of course, our x plus y equals 110, and 25x plus 10y equals 1,760. Okay, and our other equation is up there. All right, so now let's move on to the next section. Oh, there is no concentration of hydrofluoric acid which can be relied upon as safe. There is no material that is completely resistant to hydrofluoric acid degradation. That means if you put it in a container, eventually it's going to burn through the container. Okay, this is because fluorine, by the way, is so good at stealing electrons from things. So fluorine immediately starts to rip. It's the best electron stealer on the periodic table. It will steal the electrons. It has a property called electronegativity, which allows it to rip electrons off of whatever it is being contained in. As it does that, the molecules and the molecular bonds, the chemical bonds start to fall apart, and then it leaks out and causes a big problem. So let's go ahead and go to Desmos and put these equations into play. And let's see what we get. So we had x plus y equals 110, and we had 25x plus 10y equals 1,760. Let's go see what they do. Zoom out, zoom out. So there's our graph. There's our equation. Oh, look, we've got a nice, neat, and tidy point there, 4466. So 4466, label that, and I'm going to say 44 liters of 25% solution and 66 liters of 10% solution. Okay, and that is the solution, of our system of equations. So here we go. Solution of the system of equations is this. So this is the solution to the system because it makes all parts of the system true. And that's the key thing that makes something a solution. Happens to mean that it will intersect when you graph. Now let's take a look at another way of getting it. So we got our solution, 4466. Let's look at this one. So we can take that simple sum, x plus y equals 110. We could rearrange it by subtracting x from both sides, and then you get y equals 110 minus x. Or you could also say x equals 110 minus y. That would work too. So we're going to take that y, and instead of using the 0.25 and 0.10 and blah, blah, I'm going to actually use the straight up equation without any decimals, 25x plus 10y, and I think in the version you get, you'll have that version as well, equals 1,760. I'm going to copy pasta that, and I'm going to replace y with 110 minus x. 110 minus x. And now I'm going to start solving that. So that'll be 25x plus 110 times 10 is going to be 1,100. And that's going to be minus 10x equals 1,760. Now I combine like terms. 25x minus 10x will be 15x. That'll be plus 110. I'm sorry, 1,100 equals 1,760. I'm going to subtract 1,100 from both sides. And then I'm going to end up with 15x equals, well, let's see, 1,760 minus 1,100 is going to be 660. Okay. You confirm that. 0, 0. Okay, 6 minus 0, 0. 17 minus 11 is going to be 6. So 15x equals 660. I'll divide both sides by 15. Okay. And when I divide both sides by 15, I'm just going to go ahead and use the calculator to make sure I got that. 660 divided by 15 should be 44. And it is. And I get X equals 44 liters of 25% solution of hydrofluoric acid. Yay, we got hydrofluoric acid. Now we can go, oh, look, it's cleanup time. Now we can go and figure out what Y is by just taking that simple equation rearrangement from X plus Y equals 110 to Y equals 110 minus X, and we can replace X with 44. So Y will equal 110 minus X, which becomes Y equals 110 minus 44. And 110 minus 44 is going to be 66 liters of 10% hydrofluoric acid solution. And we got the same answer we got from graphing. So there we have our solution. So 66, so Y equals that. Okay, and I hope that was helpful. So just to recap, first, we came up with the missing pieces. This is a classic kind of problem. It's a mixture problem. You will actually be doing this in high school chemistry quite frequently. And you'll need to figure out how to make the proper mixtures. Probably not with hydrofluoric acid, because I don't think they're going to let you handle that. But maybe in college you will. At any rate, those are the unknowns, the two different amounts that you're mixing together. And now, once we have that information, we can create equations. We've got a simple equation. It's just the sum of the two parts, which we need to be 110 liters. And then we have a more complex equation, which is the sum of the portion that is hydrofluoric acid. And we start off with 25% of plus 10% of the other equals 16% of the total. And that can be rearranged, so it's just easier to work with equation by clearing the decimals, by multiplying everything times 100, and then cleaning this up, because it's just a product that can be something simpler. Okay, we learned that hydrofluoric acid is never safe and cannot be contained permanently. However, when we graphed it, we got this lovely intersection right here, and it gave us the solution. And then we used this tool called substitution. We substituted an expression. We substituted this expression for Y, since Y equals 110 minus X, if we rearrange this equation. We substituted it, and we were able to work out exactly how many liters of hydrofluoric acid would be the 25% solution. And then we took that information and substituted it again to find out how many liters of the 10% was there. All right, I hope that